In this video, we are continuing our quiz 2 review, and we'll do an example involving adjusting for overcounting. So the example says Pam has 5 calculus books, 4 finite math books, 1 algebra book, and 2 geometry books. How many ways are there for her to place the books on a bookshelf if, part A asks, all the books are different, and write your answers with factorials. Part B asks, the books of the same type are identical. So for example, all the calculus books are exactly the same. And again, write your answer with factorials. So begin by pausing the video for 4 minutes to try both part A and part B of this problem. 4, 3, 2, 1, pause that video. Pause it for 4 minutes to try both of these parts. Alrighty, so hopefully you've done that. Hopefully you tried both of these for about 4 minutes or so combined. So let's talk about it together. For part A, let's first think about how many total books there are. There are 5 calc books, plus 4 finite math books, plus 1 algebra book, plus 2 geometry books. And adding these, we get 12. There are 12 total books. And in part A, these are all distinct. So the number of ways to place them, we can just think about this in terms of spot by spot. There's 12 total books, so that means there's 12 choices for what book goes in the first spot. And then I multiply that by the number of ways to place a book in the second spot, which is going to be 11, because I could put anything there except for the book I put in the first spot. And then in the third spot, now there's 10 choices left, because I've already placed 2 books. And if we keep going like this down the line, eventually we'll get to the last book left to be placed, and there's only one way to put that one there. Okay, so multiplying all these, we get 12 factorial. And that's our answer to part A. So if all the books are different, we're just rearranging 12 different things, and that's 12 factorial. So part B is different because it says that, for example, all the calc books are the same. All the books of the same type are identical. So if you were to switch their order amongst themselves, it doesn't change what it looks like. So if we were to write the books with letters and subscripts, and just place them all in the order, in one order. Let's just say we put all the calc books at the front. So write C1 for the first calc book, C2 for the second calc book, and I keep going, C3, C4, C5, because there's 5 calc books. And then there's 4 finite math books. So I will call them F1, F2, F3, and F4. There's 1 algebra book, so I'll just call that A1. And 2 geometry books, so I'll call those G1 and G2. So with this labeling, just as above, we still have 12 objects. And at first glance, you know, there's 12 factorial ways to rearrange these 12 objects. However, 12 factorial says the order in which you place those 12 objects matters. So this counts the above rearrangement as different from, say, if I were to switch some of the order of the C's, so maybe I did C4, and then C3, and then C1, C5, and C2 in that order. And maybe I changed the order of the F's, so maybe I did F3, F4, F2, and F1, and then, so I can't really change the order of the algebra book. So let's just say I keep it there, so I keep A1 there. And if I swap the order of the geometry books, for example, I'll get G2 here, and then G1 there. But in part B, these two arrangements look the same for our purposes, because all the calc books are kind of in the same spot in the first 5 positions. That doesn't matter if you change their order relative to each other, because the calc books are identical. And the same thing goes for the books of the other types. So 12 factorial is going to overcount, because it's counting arrangements like these that I've drawn as different when they're actually the same in part B. So thus, writing that down, 12 factorial overcounts, which makes us a little bit sad. So let's fix this. In any rearrangement, there are, let's think about how many ways there are to permute each set of identical books. So for the calc books, there's 5 factorial ways to permute the calc books, which means we are overcounting by a factor of 5 factorial. So to fix that, implication arrow, I'm going to divide by 5 factorial. Similarly, there's 4 finite math books, so there's 4 factorial ways to permute I'm just going to write the finite books. So to fix that, we would divide by 4 factorial. And we also have 2 identical geometry books. So there's 2 factorial ways to permute just the geometry books. So we can fix that by dividing by 2 factorial. Okay, so, and there was also one algebra book, but I don't overcount because of the algebra book, because there's only one of them. So we are actually ready to write down our answer. So our initial count was 12 factorial, but we said that that overcounted. And we realized that we need to divide by 5 factorial, 4 factorial, and 2 factorial. And that's our answer. The question said to leave our answer in terms of factorials, so we'd leave it like this. We technically, if we really wanted to put a factorial because of the algebra book, we could also divide by 1 factorial for the algebra book. But 1 factorial is just equal to 1, so this doesn't affect our answer. So we don't really need to write that there.